Hi, welcome to MSc. In today's lesson, we're going to be looking at deriving the formula for the dilution of a solution. Now, to figure out how to dilute a stock solution, we need to start by talking about the concentration formula itself and making sure we understand the parts. So as a review, the C in the concentration formula is the concentration itself. It is most often going to be written as moles per decimeter cubed. You might see that as moles per liter. An alternate form of writing that would be mole per decimeter cubed and writing it as a fraction like this. Again, you can use liters instead of decimeters cubed if you want. There are other forms of concentration, such as grams per decimeter cubed, but that is not typically used, certainly not used as frequently. This type of unit can also sometimes be written just as a capital M for molarity, the moles per liter. The N is, of course, the number of moles that you have in solution, and that can usually be calculated through the mole formula, mass divided by molar mass. And then the V is the volume. And the volume will be in decimeters cubed, assuming that is the unit that you're using in measurements for concentration. So let's picture a beaker. And let's imagine that we have a water solution up to a certain level. Let's say here's my water solution line. There it is. And in this, I have some solute that's been dissolved. I'll represent it by a few dots here. So we have a concentration here we could calculate. If I knew the number of moles and the volume that I have of the water, I could calculate the concentration. So if I were to do this for my dilution, this would be my initial condition. So I would say that this would be my initial concentration. I'll call it C1. This would be my initial number of moles that's there of the solute, not the solvent, which is usually going to be water, and the initial volume. All right. If then, let's say I dumped some water into this. So I'm going to put water into the beaker to dilute it. And I'm going to raise this water level up. And let's say I raise it all the way up here. Well, now these particles that I have are now spread throughout the whole solution. They're not contained just in that first little volume. They're in the whole volume. So what I have now is I have a new concentration formula. It's my secondary conditions, C2, which is now going to be N2 over V2. So let's look at these two. Certainly the concentrations changed. One was fairly concentrated in that little bottom region. And now I've added this water in, raised the volume of the whole thing up here. And so now it's less concentrated. These particles are now free to move around throughout the whole solution. So the concentration certainly changed. And the volume has clearly changed. My volume V1 here is very different than my volume V2 up here. But when we think about the number of moles, that's the same. The number of moles of the solute is the same. So if this was table salt or an acid, that would be the same in the original and the final, because I'm not adding any more of the solute. I'm only adding more solvent. So what this means, therefore, is that actually N1 is equal to N2. Well, this allows us to rearrange both of these formulas. So I can rearrange this equation for N1, and I can do that by multiplying both sides by V1. That will get rid of the V1 on this side, and I'll get that N1 is equal to C1 V1. And likewise, I can rearrange this for my secondary conditions, and I can say that N2 will be C2 V2 through the exact same process of multiplying both sides by V2. But because N1 and N2 are equal, I can set these equations equal to one another. So instead of saying N1, I can say C1 V1. And instead of N2, I can say C2 V2. And this is my equation for the dilution of a stock solution, or dilution of any solution for that matter. If I know my original concentration and my original volume, I can calculate one of the other two values, either my final volume or final concentrations. Typically, what I'll know is I'll know my original concentration, I'll know my target concentration at the end, and my final volume, and I'm wondering how much of this stock solution I need. That's probably one of the more typical applications. But we could be sometimes looking for a new concentration. Right? I've added some water to this. What is my new concentration now? And we're able to rearrange and solve for any variety of these variables. So that is where the dilution of a stock solution formula comes from. I hope this video has been helpful. Thank you very much for listening. And as always, thank you very much for watching.